All right, our next part is to look at the derivative of sine. We've already played with this a little bit, but let's play with it some more. Once again, I want sine to be my original function, which I've been coloring in blue. So we could just type f prime here and it would show us, but that's not fun. So let's do something different. Let's say show the tangent line. And what's the tangent line formula generically? Think about it for a sec before I type it. Okay, it is f of c plus f prime at c times the value x minus c. And Desmos doesn't know what c is, so I'm going to add a slider. And let's color that, how about black? And now, let's see, we can also put a designator point at c comma f of c. And now as I move that around, Desmos is showing me what my tangent line formula is doing, so that's kind of fun. Now I'm depending on Desmos to compute the derivative here. I haven't actually found out what it is yet. I'm just kind of trusting Desmos, and that's okay when we're exploring. Well, that's so fun. All right, so let's talk about what the actual derivative function is. I can put a point at c comma f prime of c, and let's color that in red, because I usually color my derivative in red. So this will be the value of the derivative at the current point. And let's make sure it's behaving properly. Here where the tangent line is basically flat, its slope is 0, and the vertical value of this red point is 0. Over here where the tangent line has a negative slope, my point has a negative value here vertically. Over here the tangent line is even more strongly negatively sloped, and this red dot moved down as I moved to the right. See them moving down. And then over here the tangent line is less negatively sloped, so the red dot has moved up a bit. So if I track what that red dot is doing as I move along, what curve is it tracing out? Well, it seems to start high and then move down and then gets back up to a high spot again where the sine wave gets back to 0. So it's behaving periodically, so that's good. And we're getting a hint here that we already did this on paper, that our derivative is just cosine of x. So that's our guess, but let's have Desmos actually do the derivative itself by difference quotients. And we'll color this one, let's see, how about orange dashes. And so if I turn my guess on and off, I can see that they are pretty much the same curve. Or I can turn my red curve on and off. So is there another way to check that they are indeed the same curve? I mean, they're pretty close by eye. Well, you could subtract them and see if you get all zeros, or you could take their ratio and hopefully you get all ones. And it ends up working. You get that the derivative of sine is cosine. So that's great. Then the next big question is, what's the derivative of cosine? Is it sine? That would make a lot of sense. So what I want you to do is draw out on paper a cosine wave and do all this thinking about if the derivative, the slope of the tangent line is positive here, but not as positive as it is over here, and plotting the dots and stuff, and then connect the dots and see if you get a cosine wave. All right, so. All right, here we are back with paper and pencil. Our pen. So in Desmos we saw that the derivative of sine is cosine. That's a very important phrase to remember. And now I've drawn a cosine, and hopefully you did too, and you already tried this, but I'm just going to summarize it quickly. If I pick a point here and draw a tangent line, that tangent line has a negative slope. It's kind of moderately negative. So at that x value, I'm going to plot a moderately negative point. The tangent line here would have a 0 slope, so I'm going to put a 0 value there. Tangent line here would have a moderately positive slope, so I'm going to put a moderately positive value there. Tangent line here would have a pretty strong negative slope. Pretty strong positive slope, so we get that. And here I'd have a 0 slope, so I'd put a 0 value, and probably have something like that. And do the same thing over here. It's often nice to lay out where your 0 slopes are first. That kind of helps us. And over here I'd have a strong positive slope, so I'd have a strong positive value. So then if I connect those with probably a smooth curve, kind of smoothish, am I getting, well, let's pretend that was a sine or cosine. Am I getting that, so am I getting f prime of x equals sine of x? Is that a sine wave? Well, it does start in the middle like sine does, starts at the origin, but sine starts at the origin and moves up. And this is starting at the origin and moving down. So the derivative of sine is, cosine is not sine, it's actually upside down from what we expected. So the derivative of cosine is negative sine. So that negative happens lots of times and gets in our way sometimes, or we just forget it. One way to think about it that I really like, that it feels kind of asymmetric to say the derivative of sine is cosine, the derivative of cosine is negative sine. I could say, how could I get the red curve here from the blue curve? I could get it by moving the blue curve a quarter wavelength back. How could I get the red curve from the blue curve here? I could get it by moving the blue curve a quarter wavelength back. So we could say that the derivative of sine is like sine, but shifted back a quarter wave. And the derivative of cosine is like cosine, but shifted back 1/4 wave. So that's a nice way to think of it. One other thing we played with in the homework was, what's the derivative of sine 3x? I mean, it was in the backward difference quotient homework, and we did it graphically or by Excel, but we didn't do it by formulas. Was that equal to cosine of 3x? Do you remember? You could go back and take a look at it. Was it equal to 3 cosine x? Did the 3 just drop out entirely? Was it just cosine x? And the answer to all those is nope. And to see what it really is, we have to wait until chapter 2.5. So the interesting thing here was that this 3 was a new frequency term. It wasn't just a frequency of 1, it was a frequency of 3. And where did that play out? You could go back and say, it wasn't any of these, how can I modify it? And that's not a bad idea, but we'll see it more formally in chapter 2.5.